Hello everyone. On behalf of Indian National Trust for Art and Cultural Heritage and the INTACH Conservation Institutes, I extend a very warm welcome to our distinguished speaker, Mr. Carver-Kubik, and everyone who has joined us for today's talk in the Conservation Insights 2020 lecture series. I'm Dr. Padma Rohila, Director ICI Delhi. Now to introduce our speaker, Al Carver-Kubik is a research scientist at the Image Permanence Institute, IPI, at Rochester Institute of Technology, where he teaches and conducts preservation research with expertise in print and photographic processes and develops content for graphics atlas. Alice served as photographs reviewer for the National Museum of African American History and Culture's Save Our African American Treasures program since 2009. Al has a MA in photographic preservation and collections management from Ryerson University in coordination with the George Eastman Museum. Before joining IPI, Al worked in museums and galleries as a conservation technician, researcher, object preparator, and archival consultant. He's co-author of In the Darkroom, an illustrated guide to photographic processes before the digital age, published in 2009, and has contributed research about photographic materials to several other publications, including the Thames and Hudson Dictionary of Photographs 2015, the Platinum and Palladium Photographs Technical History, Connoisseurship and Conservation 2017, and the latest, the Preservation Management Handbook, 2nd edition 2020. The title of today's talk is Graphics Atlas, Photographic Identification and Care. Graphic Atlas is an online resource that presents a unique object-based approach for the identification and characterization of prints and photographs. This presentation will demonstrate a structured methodology to print and photograph identification, how to use Graphics Atlas as a reference resource. In addition, we'll also share a sneak peek on new content that is currently being added to the site. So thank you, Al, for first of all giving us this opportunity. Thank you very much for the presentation. And before I invite you, may I please request all our participants to mute their microphones. The questions will be taken up right at the end of the talk, so please keep typing those in the chat box and also type in your name, organization name, and email address. Thank you, Al. Over to you now.
Thank you so much. First of all, I'd like to thank you so much for having me and for giving me the opportunity to share this information with you. I'm very excited. So I'm going to go ahead and share my screen. And there we go. Okay. So first, I'd just like to tell you a little bit about Image Permanence Institute. We are a university-based research center. We focus on cultural heritage preservation research. So we do several things in that area. We do research on physical materials that are often found in cultural heritage collections. Based on that information, we provide resources for preservation. We also have some products and services. We consult with institutions to help improve their heating and air conditioning systems for better preservation quality. We also have an online data preservation database called eClimate Notebook, in which you can upload your environmental data that you collect on your spaces, and it graphs it out and also helps you have a better understanding of what the preservation quality of your storage facilities and galleries are. So all of that sort of feeds into each aspect of our institute: the research, the educational tools and resources, and then also the consulting. So one of the things that we focus on are print-based materials, particularly photographs and printmaking processes. And in order to really be able to preserve and care for your collections, it's really important to understand the materials and the physical aspects and kind of know what you have in order to preserve them. And so sort of from the beginning of IPI until the present, one of our major focuses has been in education and training individuals working in cultural heritage institutions on how to identify their photographs. and therefore also how to care for their photographs. And so this presentation is really focused on identification as the first step to preservation. Okay, so one of the things that I love about photography is that there are many histories of photography and many technologies that converge. Photography touches nearly every aspect of our lives. No matter what discipline one goes into, somehow photographs are involved. And when it comes to the technologies, we have the cameras and optics, we have photographic negatives, and we have photographic prints. Photographic prints are often very difficult to identify. Many of them look very similar to one another, and we'll get more into that. And so many of our resources really focus on understanding photographs and photographic prints. So this begs the question, what exactly is a photograph? Our sort of pure and traditional definition is it's an image formed using light-sensitive chemical compounds, and it's on a substrate. Light-sensitive chemical compounds can be silver-based, silver halides, or silver salts. We also have iron-based processes and chromium-based processes. And of course, that has to be on something, on a substrate of some sort. That definition shifts when we enter into the late 20th century and 21st century, into the digital age, of course, because these photographs are made by essentially light and electronic signals. And we still consider those photographs. For those of you who are interested in the chemistry, I have the sort of chemistry of basic silver based photography here at the bottom. So in order to understand how to identify photographs, I find that it's very important to understand the physical materials, as I said earlier. And so I'd like to start this presentation really talking about the building blocks of photographs. And we'll sort of start from the ground up. But basically, we have a primary support. We have some kind of image material. Often, but not always, there's something called a photographic binder. Sometimes there's additional coatings and other additives and things. Our simplest photographic prints are a one-layer structure. We have the silver image in the paper support. These are very early photographs, introduced in the sort of late 1830s, 1840s. And so you can see that here is our photograph here. It's a salted paper print. If I were to flip that print onto its side and zoom in and magnify about 200 times magnification, we get the layer structure, which is here. And you can see that this brown coloration is the silver image in the paper support. So the image actually forms within the paper, and we call that a one-layer structure. Other photographs that have a one-layer structure come later, such as the platinum print and the cyanotype. One of the concerns, or one of the criticisms of this one-layer structure salted paper print in the early 19th century is that the image is sort of soft. Because the image rests in the paper support, you can't get as much detail. So in order to get a little bit more detail in the image, it was thought to add something, right? Add another layer onto the paper support. And in this case, we added albumin. Albumin is egg white. So you basically take egg whites and you whip them up, you froth them up, and you add the salt of the silver salt to the egg white, and you coat that onto the paper support, and then you sort of dip that into the silver nitrate, and you get your light sensitive compound, your silver salt, your silver halide. And so the image actually forms in the albumin. We call it a binder because it holds the image, it sort of binds the image. Oftentimes you will hear the binder also called an emulsion. It's a bit of a misnomer. I prefer binder. An emulsion is technically a liquid suspended in another liquid. In this case, we actually have a particulate, a solid, suspended here in the albumin. So that's why we prefer to call it a binder, because it sort of binds and holds. And then, of course, we have our paper support. And here we get a little more detail. We get more detail in the shadows, more detail in the middle tones and the highlights too. In order to get even more detail, later in the 19th century, in the 1880s, it was thought to add yet another layer, an intermediary layer called the bridal layer. The bridal layer is gelatin with a white pigment, barium sulfate. And so that is coated paper before the binder layer is added. So you have this nice thick bridal layer completely covering and obscuring your paper support. And then the image forms in the binder, and the binder is on top of that. In this case, it's generally gelatin or collodion. Gelatin, of course, is made by boiling down connective tissue and bones of animals, usually cows, and where you get sort of this viscous substance, gelatin. Collodion is cotton dissolved in nitric acid, which forms sort of a plastic, and then you can then dissolve that plastic into ether and alcohol, and you get, again, this sort of sticky viscous substance that hardens into kind of a plastic. Those were all silver-based. In the 1880s, iron-based processes, oh, I have a typo there, sorry, that should say layer. Iron-based processes, or at least the platinum print, was introduced. The cyanotype, which is the image material is Prussian blue, was actually introduced in the 1840s, 1842, in England. And it wasn't really popular really until the end of the 19th century and into the 20th century. And these are both one-layer supports. Our dichromated colloid processes, while technically introduced in the 1839, didn't really become popular to the 1850s, 1860s, such as the carbon print, and then later the gum bichromate. And these tend to be 2 or 3 layers. Technology progressed, and in the 20th century, color photographs are introduced. The image materials are usually dye or pigment. They all have a gelatin binder. The support might be plastic or paper, most commonly paper, but plastic is certainly found. And they often have, but not always have, some sort of support coating. And then, of course, we have digital materials. And digital materials include lots of different kinds of materials. The most common primary support remains paper, but you can print inkjet and dye diffusion thermal transfer, most commonly known as dye sublimation, on pretty much anything, on coffee mugs, metal supports, fabric, you name it. So now I'll jump into identification. How do we go about identifying these objects? So again, here we have our salted paper print, albumin print, or gelatin POP. They all look very similar in terms of their image color, as well as all sort of being 19th century. And then we have our dye imbibition, our chromogenic, silver dye bleach. Another color process is the Carbo process, and they're all full color. So they all look very similar to one another. So how do we begin to separate these out? Because now we've seen that the image materials are very different, or all of the other sort of building blocks, right? The supports, the binder layers, some of them have intermediate supports, and all will behave differently in different environmental conditions, high relative humidity, low relative humidity, high temperature, low temperature. So how do we begin to really understand how to identify these objects? And so each object has what I call key identifying features. Think of it as a fingerprint for each object or each type of photograph. And these features are a direct result of the materials and technologies that were used to make the photograph. So one of the reasons why I really emphasize understanding the materials and the layer structures is that gives you the clues to these key identifying features. To understanding how these things are made can help you better understand how to identify the objects. So we have this sort of method of looking. We start with an object view, then we move to a surface view, and then we move to a magnification view. And I'll walk you through each of these steps. With the object view, we focus on characteristics that are visible with just even illumination, no magnification, just sort of turn on the overhead lights and look at the object. The key identifying features that we're looking for are the support material, image color and tone, and sort of the quality of the image. Is there any distinctive deterioration? While deterioration is undesirable, it often can help us better understand what kind of object we have, what kind of photograph we have. There's also extra information that we can collect. Things like image clues. Is it on a common format or common mount? Is there any information written on the object or printed on the object that might help us better understand a date, perhaps? So I'll start actually with this extra information because it really can tell us quite a lot. So when we look at image clues, if it happens to be a portrait, we can look for things like clothing, vehicles, hairstyles, then it can help us narrow down a date. And if we can narrow down a date, we can definitely narrow down the process options. Are there any buildings in the image? Maybe you might know when a building was built, and that might narrow down. And again, is there any information written or printed on the object? You know, here we can see that it says January 63. So that narrows it down quite a bit. January 1963, it's black and white. That makes it pretty easy. And even if we didn't have this date here, I know this is a very American image, but the fact that this little boy is dressed in this sort of cowboy outfit would lead me to believe it's 1950s or 1960s. Format, there are common formats. Again, these are American dates, and this is sort of very American centric. But there are these sort of common mounting and sort of presentation formats throughout the sort of 19th and 20th century that can also help us to narrow things down. Okay, so here I have my little thumbprint here, so we know this is a key identifying feature. One of the things we'll notice right away is our support material. Is it on paper? And again, that paper may be mounted to another piece of paper or a cardboard mount or sort of a board mount. Is it plastic? Is it a glass object? Is it a metal object? Less common are ceramic, fabric, and leather, but they certainly do occur in collections. And this can help us narrow it down. If it's on anything other than paper, it narrows down the options to just a few things. If it's on a paper support, then we have a lot more work to do. The next thing we'll look for is image color. There's kind of a trick to looking at the image color. The first thing we want to do is we really want to look at the image itself and ignore the highlights. One of the tricks that I like to do is I take an index card and I use a hole puncher and I punch a hole in it so that I can sort of lay that over the photograph and just isolate kind of the middle tone area. And the middle tones give us a really good idea of what the image color is. The highlights, depending on the process, you can have deterioration in the highlights, or your highlights can be purposely tinted a color like pink or blue, or they can be sort of a warm white or a cool white, and that kind of shifts our perception of what the image color actually is. So we really want to isolate kind of a middle tone. And we'll look for the most common image colors, which are black. We have this sort of purple red, brown, yellow. Photographs can also be pretty much any color under the rainbow, or we can have full color, full chromatic images, and then which are not to be confused with things that are hand colored. Another really important tip to looking for image color is to look at the photograph under daylight balance light. If you're looking at it under fluorescent lighting, everything shifts to the green. Our eyes and our brain are really good at sort of color balancing, if you will. So we don't always perceive that our light has a color to it. Once you begin to get used to it, understanding that and seeing that, you do start to perceive it. Tungsten light tends to be a little sort of red, orange, so everything will sort of shift in that direction. So what you'll want to do is get a good daylight balanced light bulb for your lamp or for your overhead lights, and that will actually give you a better indication of the true color of your photograph. As a side note, what we did to create this chart, and I'll show you where you can find this on our website, is we have a very large research collection. And so we took lots and lots of photographs out of our research collection, and we reorganize them. They're organized by process, but we reorganize them by color, and these are the colors that emerged. This yellow color is not a desirable color. It is specifically the color of image deterioration, of silver image deterioration, but it's so prevalent in photographs, in silver-based photographs, that it actually emerges as a color. The next thing we'll look for is deterioration. Highlight yellowing is really common with albumin prints. We can also be found in anything with a gelatin binder. Silver mirroring or bronzing are characteristics found in anything that has a silver-based image, or at least it's possible to have it in a silver-based image. We can have image fading in silver-based images, as well as color, some color photographs, color shifting in some color photographs. Image ghosting is most common in photographs that have platinum. So whether it's toned with platinum or the image itself is platinum, but you have to be careful because this can also happen under rare circumstances with silver and with anything that's ink on paper. We call them different things when these happen with anything that's not platinum, but it has a similar effect. So then we move on to our surface view, and these are characteristics that are visible with directional illumination and no magnification. We use a simple light source from above. And you can see, here's my model here. Her name is Erin, and she worked with us at IPI as a student intern for a while. And you can see that she's holding a flashlight just a couple inches above the photograph. And I'm actually gonna stop share so I can demonstrate this. So what we'll do is we'll take our flashlight, we'll hold it a couple inches above the photograph, and I'm gonna stand up here. And then what you'll wanna do is you'll want to align your head so that it is directly above your light source, directly above your flashlight. If you look at it from an angle like this, you'll just see that you're illuminating the print. You won't get that surface sheen, that sort of ball of light. So what you wanna do is adjust yourself. Here, I'll back up a little bit. So you're looking right down in line with your flashlight. This is a really nice way to see surface characteristics, particularly if you're not able to touch the photograph. First, you'll want to assess the condition of the photograph. And also, you know, in some collections, in some instances, you're just not allowed to touch the photograph. And so that gives you sort of a really nice way of looking at surface characteristics without touching. If you are able to touch the photograph, the other way is just to sort of manipulate it under the overhead light and get the sort of surface reflection of your overhead light. So again, we separated these characteristics out into just sort of a few main surface characteristics. We have matte, where there's just no reflection at all. Semi-matte, where there's a little bit of reflection coming back. Glossy, and high gloss. High gloss is often reserved for things that are on plastic or glass. And then we also have characteristics called differential gloss. This actually has two sides to it, this chart. Differential gloss is where there's a difference in gloss between the shadows and the highlights. One may be glossier than the other. And then there's iridescence, where it gives you that sort of soap bubble characteristic, well, that sort of pink and green colors in the reflection or in the little ball of light. And that's often characteristic of collodion binders, as well as the surface coating on dye sublimation prints, or dye diffusion thermal transfer is the technical name. Then we move on to our magnification view. These are characteristics that are visible with even or directional illumination and the use of some kind of magnification. What we're looking for are image structure and layer structure. So first of all, I'll talk about the tools of magnification. There's the 10x loop. I don't know if you can see me, but I have a loop here. There's a pocket microscope, and then there's your sort of stereo microscope. And with each of these, you get sort of different levels of magnification, and you can see different characteristics. For some objects, less is more. Lower magnification is preferable to higher magnification. This is a salted paper print with a 10x loop. We get about that much detail. With a pocket microscope, we get a little bit more, and with a higher powered stereo microscope, we get a little bit more. A note on the stereo microscope, I prefer the kind that do not have this platform, because with large photographs, you don't really want to balance it on this platform. So you can find models that don't have a platform. But not everybody has access to a stereo microscope. They can be expensive. So a pocket microscope for identification actually does pretty well. So with your loop, you can put it directly on top of the photograph. I recommend always putting down a sheet of polyester down, like clear polyester, so you're not putting your magnification tool directly on your photograph. Alternately, you can turn it upside down so you have the cup to your eye, and then you can use a flashlight to illuminate the area where you want to look. If anybody has used the loop, you notice that as soon as you lean over to look at the photograph, your head blocks the light and everything goes dark and you can't see anything. So just holding a flashlight in one hand and looking with the loop in the other works really well. With the pocket microscope, you have to put the microscope in direct contact with your photograph. So you may or may not be able to do this depending on the condition of your object and the collection. If you are able to do that, make sure you put down a piece of polyester sheeting so that you're not putting it in direct contact, your microscope in direct contact with the object. You also want to make sure you focus off the photograph on the table or onto a piece of paper next to you so that you're not pushing down on it using the focusing ring. Also, as you're moving to look at different areas of the photograph, you want to pick up your pocket microscope and set it down gently. Always look in a mid-tone area when you're looking with magnification. There's too much information in the shadows and not enough in the highlights to really see what we're looking for. So what are we looking for? We're looking for our image structure. Is it continuous in tone, or is there a distinctive pattern to the image? That's the first thing we look for with low magnification with our loop. Continuous in tone means that between the highlights, the midtones, and the shadows, it sort of is even and smooth, right? It just sort of continuously blends from shadow, midtone, highlight. A pattern is you'll distinctly see dots, squares, squiggles, lines. Sometimes we'll see pigment particles. We can see that here. With high magnification, our continuous in tone images, it begins to break up into kind of an image grain. We begin to see this sort of grainy appearance, which is not to be confused with like dots and squares. We're also looking for image structure. Image structure, again, is it a one layer? Is it two layer? Is it a three layer? Obviously, we can't make cross sections of all of our objects. So what we're looking for are the paper fibers and where the image rests in relation to the paper fibers. So on a one layer structure, the paper fibers will be very clear, and you can begin to perceive this. This is what I call advanced identification. With practice, you'll begin to perceive that the image is actually in the paper fibers. With objects that are ink on paper, again, you'll often see a distinctive pattern, but you'll also see that the image kind of rests on top of the paper fibers and it looks sort of inky. For a two-layer structure, we can see the paper fibers, not as well as with a one-layer structure, but we can definitely see them. But we can see that they're sort of coated with something. And we can also see that the image kind of floats slightly above the paper fibers. This can be difficult to perceive and it takes practice. Another trick is to look at the edge or the corner of the print. And sometimes you can see that there's little areas of loss in the binder. And you can actually see that there's separate layers there. And then finally, if you have a 3 or more layer structure, you won't see paper fibers at all. It'll look smooth. You might see sort of pits and bumps and scratches and things, but you won't see paper fibers. If you have trouble with this as you begin to practice, don't worry about it. It takes practice, it takes training your eye, but you can actually get really close to identification using Graphics Atlas, and I'll show you how to do that in a minute here, without this step. So in order to really make those paper fibers jump, to really be able to see them clearly, we recommend raking light. And that's taking your flashlight and putting it at kind of a 90-degree angle from your object. So the light rakes across, and you can use your loupe or you can use your pocket microscope. Most pocket microscopes have an internal light, so you can turn off the internal light and use your flashlight to do a raking light. Again, put down a piece of polyester sheeting so that you're not in direct contact with your object. So let's put it all together. Here we have our salted paper print, our albumin print, and our gelatin printed out print. Again, they're all very similar in terms of image color. I would all call these kind of in that brown or purple red range. But as we look at these with our surface view, which is here in the middle, we can see that the salted paper print is very matte. The albumin print is sort of semi-matte, and our gelatin printed out print is glossy. If we look at these with magnification and raking light, we very clearly see our paper fibers here. We definitely see them here, and we don't see them at all with our 3-layer structure. And of course, I have the cross section, so you can sort of correlate those things. 1-layer structure, matte paper fibers. 2-layer structure, semi-matte. With the 2-layer structure in the 19th century, you will almost always have a little bit of a surface sheen. In the 20th century, all the rules kind of go out the window in terms of layer structure and correlating surface sheen. With the 3-layer structure in the 19th century, you'll almost always have kind of a glossy surface or differential gloss. Again, in the 20th century, we can include other additives to this 3-layer structure to make a semi-matte or very matte support. We can add texture, we can add things called matting agents, which are little particles of silica or starch, and to create a bumpy surface that gives us something more matte. But this is our 19th century. It's pretty simple and clean. So now I'd like to show you Graphics Atlas. Here we go. So the URL is www.graphicsatlas.org. And I will tell you that we're working on redesigning Graphics Atlas, and I'll show you a couple slides about that at the end here. But this is how it is for now. And all of the features that I'll show you will still be in the sort of redesign of Graphics Atlas. They'll just be in different places. So the first thing I'd like to show you actually is the compare module. So here we have browse, we have search, and we have timeline. The browse is just, it gives you all of the processes. So if you think you know what you have, or you literally just want to browse and sort of look at things, this is a good start. If you don't know what you have, you can use the methodology that I just described in this search function. So what you'll do is you'll first say, what is my primary support? And we'll take the objects that I just showed you are, let's see, salted paper print and albumin print, right? We'll say, well, we have a paper support on both of those. Then we look at our image color and we'll say, well, they're both kind of purple red. And even if we all see color differently, so even if you think they're kind of brown, you can select that. We can do some trial and error here. I'm going to leave image deterioration alone for now, but you can certainly click image deterioration. You can have multiple different kinds of image deterioration. Then so you can click multiple things. Let's say our surface sheen is semi-matte. And I can go back to the PowerPoint slide that describes that here, right? So we can say it's sort of in that brown color, or that purple red color. We'll say we have a semi-matte. We looked at it with magnification, and we see that as continuous in tone. If you look with higher magnification and you think you see image grain, you can click that. If you think you see pigment particles, you can click that. And then we'll say we see our layer structure, and we're pretty sure it's this 2-layer structure. The image is above the paper fibers, and it's in a binder. So we click that. Okay. That narrows us down to 12 objects on the site, which is really 1, 2, 3, 4 processes. It gives us this silver gelatin selenium toned photograph. If we were to look at the timeline, we would see, oh, that's solidly 20th century. If I look at my photograph, I might say, I'm pretty sure this was made in the 19th century. So we'll throw that out. It gives us a lot of albumin, so we can start there. And then I'll also note that we have this carbon CDV. So we'll click that. And then I'll also go in here and I'll find the carbon CDV. In the updated version of this site, you'll be able to select multiple things and put them kind of in a basket and then be able to look at them here. So you won't have to like sit and remember. So here we can say, yeah, I definitely have these purple image tones. We can change our lighting and go, oh yeah, this is semi-matte. And we can actually zoom in here and say, oh, this one actually has differential gloss. The carbon has differential gloss. The shadows are glossier than the highlights. I don't have that in my photograph. I can continue to magnify. This stage here is about 10 times magnification. So that's equivalent to your loop. This is about 30 times magnification. That's equivalent to sort of a low-powered pocket microscope. And this is 50 times magnification, which is equivalent to a higher powered pocket microscope or your stereo microscope. So here I actually see pigment particles. You see these little dots dispersed throughout even the highlights and middle tones as well as the shadows. Those are pigment particles. This is continuous, they're both continuous in tone. This is continuous in tone with pigment particles. If I use raking light, I can see that my paper fibers jump out at me. So I definitely see paper fibers. So you can use this tool, again, sort of use the methodology, make these simple observations, narrow down what you have, and then use Graphics Atlas to then verify that the characteristics you see in your photograph match characteristics of an object on Graphics Atlas to help you know what the process is. Here I could, oh, actually, let me go back to where we were. Here I have my key identifying features under the what to notice, purple red image tones. We do have highlight yellowing, semi-matte surface sheen. It's continuous in tone. And then of course, our layer structure. You can look at the back of the object. You can look at the cross section of the object. We also have little videos which give you that sort of as if you were manipulating the object under the light. The other features are the guided tour. I literally guide you on a tour of this object. So what we do is we give you characteristics that are specific to this object, as well as characteristics that are common for all albumin prints, which is the process of this object. And we also have something called our identification pages. And this is just sort of the information dump. You can see that it's organized in object view, surface view, magnification. We also have variations. In our overview, we give you common use states. Again, these are United States or American common use states. I need to do more research to have more international common use states for processes. That's something I'd like to add in the future. We have alternate names, key identifying features that are illustrated here, common mistakes, kind of how do we put these together, these objects together into families. It's a silver, it has albumin binder, a paper support, and then a description. The object view, again, is that support material, and it talks about what kind of support it has and why, and then kind of your brief summary, right? Kind of what do you need to know? Again, why are albumin prints the colors that they are? And then your quick kind of like, what do I just need to know? Again, illustrated, and all the illustrations can be enlarged. This is a contemporary albumin print. Mounting formats, finishing techniques, all of those things. Surface view, very similar. Surface sheen, surface textures. Then we have our magnification, image structure, increasing magnification, layer structure, views. And variations, things like matte albumin, collodion glazing, things that you might find in collections. We also have our interesting picture of the month. we send an email out once a month where we just send you an interesting object from our collection. And we have a little write-up about it that sort of puts it into context and a little bit of information about the process. You can sign up for that if you'd like here on our website. You can click here. And again, it's just an email a month with an interesting object from our collection. So just to wrap up, I'm going to come back to my PowerPoint here. And as I said, we are changing Graphics Atlas. We are sort of redesigning the site. This is kind of the rough view. It's due to be launched probably January, February 2021. And so you can see that now we'll have Explore, Identify, Preserve, and as well as Picture of the Month. We recently received a grant in 2019 from the Samuel H. Kress Foundation to create preservation content. So now not only will you be able to identify what kind of photograph you have, but you'll also be able to access information on how to care for it. So you can do first step, what do you have? Next step, how do I care for it? I'm very excited about that. We'll have identify and preserve. So the identify again will kind of also help you work through how to identify your photographs, and explore will help you kind of explore these different materials and objects. So yeah, this is just kind of a quick screenshot of the staging site that we have. Again, we're just sort of still working on the design and transferring over the content that's currently on the site into the new site. The preserved content is going to be data-driven. It's going to be based on scientific research. It's based on research done at Image Permanence Institute, as well as research done at other research institutes throughout the world. So this is just a graph to show you that it's data-driven. This is research that we did in which we looked at the moisture equilibration rates of collection materials. So this happens to be a book. And we can see that the ambient relative humidity is doing this in the red, and in the blue is what the inside of the book was doing. So the core of the book. Similar to the current identification pages, we'll have this sort of big picture. Why is it deteriorating the way that it is deteriorating? What's happening? And then we'll also have these sort of call outs, these sort of special considerations of exactly sort of what's happening. So here I have a silver gelatin developed out print from the 1920s, and we have silver mirroring. And so I have sort of this information that describes what's happening and what's causing it to happen. And then of course we'll have our recommendations on how to care for this object. We'll have instructions such as this on how to make different kinds of housings that are really common. So this is called a phase box that you might use for a cased object like a daguerreotype or ambrotype that are in cases, or an album bound volume album. So we've really easy to follow instructions on how to make one of these. Similarly, for things that require low temperature storage, such as frozen storage, if you have a freezer that doesn't have relative humidity control, you can make these vapor-proof packages. You can find on other resources how to make these vapor-proof packages, but we made this really simple visual diagram with instructions on how to make one. Yeah, that's all I have. I'm excited about these new preservation pages and this new content. I'm going to sort of back up here. And I hope that you will come look at the site now and then come back and continue to use it and use it in the future and look for the changes that we'll be making. I'll stop my share in the future. Hopefully this was helpful. If you'd like to look at this again, or I understand this will be recorded and posted. We also do on Graphics Atlas currently, actually let me go back to my share screen. We do have some videos here. We have one on print and photographic materials, which kind of gives an overview of materials. I have one on the sort of methodology and this vocabulary we've created for identification, and then one on using Graphics Atlas for identification. I prefer this sort of teaching format of the webinar and this kind of face-to-face. But if you really need a refresher, there are some videos. They're only like 5 to 10 minutes each. So.
Thank you very much, Al. I think I really found it very informative. I think most of us did. There
Thank you.
are 2 questions. If
Great.
you're ready, we can start with that.
Yep.
The first question which we have is, what color rendering index is the source in the source slide would you suggest we use while examining the photographic collections?
That is a good question. Let me think about it for a second. Yeah, anything that's considered daylight balance, which is, I might be wrong, but I think is around 5,600K. Yeah, kind of around in there. Honestly, it doesn't have to be exact. I find that I got from a crafting store, one that we have here in the States called Joann's, and I just got like a basic OTT, OTT, I think it's called, that has a daylight balanced fluorescent bulb in it. You can buy daylight balanced bulbs for your light fixtures, your lamps. I find that to be good enough. Really what you don't want to use is anything that's fluorescent lighting because it's very green, anything that's tungsten lighting because it's very sort of orange. I did forget something. I'm going to actually go back to my search. Those PDFs are here on the site. So again, in the search function, we have our visual guide for color. You can download this and print this. We do have a little warning that your computer monitor and printer calibration may be off or could vary. So I'd say make sure that you have your monitor calibrated and you can look at this and it'll look great. Or make sure that the calibration between your printer and your monitor are good when you print this out because it can go weird.
Okay.
We have ones for deterioration and again, surface sheen, right? So those are there, yeah.
Thank you. Now the question is, will the use of a digital microscope, something like a Dinolite, be better over a pocket microscope to examine photographs in magnification? I mean, those are more common, I believe so.
Yeah, I would say depending on the optics equivalent. Pocket microscopes vary. I have this one. This is not by any means a product promotion. Where's my box for it? I don't know what I did with it. Oh, here it is. It's the Carson Microbright. I like it. I've spent a lot of money and a lot of time finding a pocket microscope that I like. And this is the only one that I find that the magnification level is adequate and the optics of it are adequate for what I need for identification. And so this is really great and it's cheap. It's like $12 US. So it's as far as pocket microscopes go, it's not super expensive. I find the digital microscopes can be very expensive if you want to take images or you want to do identification in front of a group for a class or a lecture. It's great. And I'm actually looking into buying one for exactly that purpose. But we scoped them out and they can be over $100 or several hundred US. So it really depends what you want. If you want a decent pocket microscope that's inexpensive just for yourself for looking, this is great. If you want something that's digital that you want to be able to take images or be able to project it for others, get the digital.
It'll work as well. Okay, thank you. Could you please briefly explain the process of making a cross-section sample of photographs with a paper substrate?
Yeah.
Could you explain that?
Great question. I wish I were in my lab. Normally I would do this from the office. It's early in the morning here, so I wasn't going to make it to the office. But what we have is a microtome, which is an apparatus that is used to make cross sections, typically of like biological specimens, right? And so you mount them in resin. But ours has been modified, so typically you mount the specimen and it comes down over the blade like this. Ours is reversed. So we mount the specimen onto the table, and the blade is here, so like a guillotine almost, and it comes down. So that's what we use. And again, it's electronic, so you can adjust it. So you can do 2 microns, 2 micrometers, 4, 6. I think it does by increments of 2. And so our cross sections are anywhere between 2 and 10 micrometers, so like thinner than hair. We then mount that to a slide, and we use a Stoddard solution so that the material doesn't swell, but it also doesn't bounce the light around, And then we image it under a compound microscope, and so at 200 times magnification. So I know people who have done it with by hand with a razor blade. That was initially how we were doing them 15 years ago, before I was even there. But it's still variable, and you can't get to the thinness that you need. So a colleague of ours named Ralph Wiegand modified our microtome. So we have a modified microtome. The National Gallery of Art has a modified microtome. That might be it to make cross section in this way. But certainly you can do it. It's easy. I mean, relatively easy to do.
Okay, thank you.
Yeah.
Next question is, what is the update schedule of the graphics atlas with the constant development in digital printing?
Good question. So graphics atlas, like any resource in a not-for-profit, is that we have to get funding to continue to work on it. And so I try to keep up with the digital print material as best we can, and keep adding objects and information to the site. However, we do have an entire research wing at IPI dedicated to researching digital print material. And we have another resource for that called DP3 Project, Digital Print Preservation Project. The website for that, I'm just going to go and put it in the chat, if that's okay. It's, I'll say it out, it's www.dp3project.org. There you go. And so all of our research dedicated to digital printing, that's sort of the place where it goes. All of our recent research, all of our older research, and we also try to keep up with identification and sort of materials understanding on that site. We also have a site for film identification and preservation called filmcare.org. I'll put that in the chat too, if that's okay. Filmcare.org. Okay.
Thank you so much. I don't see any other questions. I think all of us need to just maybe go there on the site, have a little go around, and then maybe we'll have your questions. Is it okay, Al, if you share your email ID with the team, if in case people have, can you just put in your email ID in the chat box as well? So that
Please do.
Yeah, can just put it there so that if people have any questions, once they visit the website, they can definitely get in touch with you. If there are any queries, yeah, that's the email ID for everyone. So I think, okay, I think we have another question. It says, okay, would you suggest using the same methodology for examining negatives with respect to gloss?
Not exactly. Because negatives are sort of, this methodology works best for print-based objects. And it's really intended for print-based objects because there's so many different kinds. They all look very similar to one another, and oftentimes intentionally. With negatives, the first thing you'll want to do is identify which side has the binder and the image on it. And so the side with the binder and image will be less glossy, right? It'll be a little bit, like it'll have a sort of slightly different characteristic. And we do have glass plate negatives on the website. So we do have gelatin dry plate and collodion on the website. Anything on a plastic support, you can find on filmcare.org. But in either case, you will see that the binder side is a little more matte, and the sort of glass or plastic side is more glossy. And the main thing you want to do is so that you know where the binder is, so you don't damage it or scratch it. And then when it comes to identification, The difference between the collodion and the gelatin, once you've sort of really looked at them, starts to become kind of obvious. With the collodion, you'll have those sort of drip lines along the edge because it's hand poured. With gelatin, everything goes right to the edge of the plate. Gelatin dry plate tend to be kind of a more neutral black and white, unless there's like distinctive chemical treatment to them. You could sort of do reduction or sort of boost them up or reduce them chemically, and that kind of changes the image color. And with collodion, they can actually be a range of image colors for the same reason. But again, you'll have all those characteristics. And with determining the difference between acetate and nitrate can be very difficult. If it says safety, it's acetate. If it doesn't, it can be either. With polyester, you can use, sorry, I'm losing my words here, polarization filters, and you can get those sort of, polarization effects. Again, that's on filmcare.org, but yeah, there's other ways, other techniques to use for negatives for sure, and positive transparencies.
So I think those are the questions. Thank you so much for your time. And I think
You're very welcome.
presentation very well presented. Okay, another question.
Okay.
So the next question is, how common would you say are the presence of unvarnished glass plate negatives? If sorry, there's a second part to it. If a collection had a large number of such negatives from the late 19th century, how would you go about caring about them?
Yeah, that's a good question. I would say, like in the United States and Europe, on unvarnished collodion negatives and positive transparencies, as well as tintypes and amber types, or ferrotypes and what collodion positives, depending on where you are relatively uncommon. We have a few in our collection. In other places in the world, I just don't know. And again, I need to do more research sort of outside the US and Europe. One way that you can tell if it's unvarnished is you might have image deterioration. Varnished images often don't have deterioration. Sometimes with varnished ones, like you'll have like a little corner or edge where the varnish missed, and you'll have like silver mirroring. You'll have that sort of fine silver deposit on the surface. If it's completely unvarnished, it's like at this point, roughly 200 years later, it's likely to have some silver mirroring, some silver image deterioration. You might also have really serious abrasions. The purpose of the varnish was to protect the silver image, but also to protect the binder from abrading, because that collodion it abrades very easily. So that's one way that you can tell. Again, I don't know how common they are in other places in the world. If you do think that you have unvarnished negatives, the first thing I would do is to be very careful in handling them. Make sure you always have them binder side up. I would house them individually in 4 flaps, make the sort of paper 4 flap sleeves. Always house them vertically. If you house them horizontally, they're too heavy and the weight will actually crack the ones on the bottom. And I would keep them in as cool storage as you can, and with moderate relative humidity. So moderate relative humidity means anywhere between 30% RH and like 55, 60% RH. 60% RH is getting a little high. I know that is a challenge depending where you are and what your resources are, but that is the goal. I know, like, for example, in the United States, in the southern United States, it's so humid there, photographs and physical materials like just don't survive. So in really humid areas, it's a challenge. And cool, I mean 40 degrees Celsius, sorry, 40 degrees Fahrenheit. I can't do the conversion in my head that quickly, but let's see, if 20 Celsius is roughly 60, 70 Fahrenheit, so yeah, that's those are my recommendations, and kind of how you can tell. Gelatin dry plate are usually unvarnished.
Okay. Thank you. I think you said 40 degrees Fahrenheit is about 4 to 5 degrees Celsius.
Okay.
Yeah. Okay, we have a quick.
Thank you.
You're so welcome. I have the phone.
Yeah, it's like,
Thank you. The next question is, we use UV light to examine if varnish is present or absent on glass plate negatives. Do you recommend it? Is it a good way to do the examination, or do you think there's a risk of any damage while doing this?
Yeah, good question. So with UV light, you can determine sometimes if there's a varnish. I believe there is a section about that in Graphics Atlas when you look at the collodion wet plate identification page. So some varnishes do fluoresce, and that's a good way to tell if there is one. If you're doing just a really quick UV examination, it's not going to cause that much harm. I don't believe. Silver itself. So we think about silver as being light sensitive, and the truth is there's no scientific information that says that silver itself is particularly sensitive to light. When we display things and we expose silver to light, it's usually byproducts of deterioration from other aspects of the photograph, maybe the mount, for example, or the support, that actually come off and then interact with the silver to cause light-induced fading. Your binder may be more sensitive to the light than the silver itself, so that's the thing to be careful about. If there's any hand-applied coloring or retouching that isn't sort of carbon-based ink, that can be very sensitive to the light. The coatings themselves may be sensitive, depending on what the coating is. So in short, you can use UV. It doesn't always tell you if there's a varnish or not, and if it's really quick, just to see if there's something there, you're probably okay. And it's a nice technique to use. So, yeah.
So, is there any way to differentiate between different varnish materials using UV light examination? Even within that, is there a way to differentiate?
Yeah. You know, one of my interns looked into this, and it was several years ago, so my memory of it is a little fuzzy. I think that sometimes yes and sometimes no. Different varnishes will fluoresce different colors, and off the top of my head, I really don't remember what they are. But sometimes things will fluoresce the same color, so it's hard to tell. And sometimes you might have a varnish that doesn't fluoresce at all. Yeah.
Okay, so any other questions? Everyone, be very quick to type them in. I don't see any. Okay, the moment I say a goodbye, that's when a question pops. So I think I'll thank you so much.
Always email it.
Yeah, everybody has your email. I'll be going through the site myself, taking some time. I think
Great.
given some simple practical ways for differentiating, and I think everybody will have a look at the site. If you have questions, we'll be back with you. Thank you so much.
Thank you so much.
Talk. I know it's early in the morning.
Oh, it's fine.
And you took the time out, and I'll be again in touch with you. Thank you everyone for joining us, and thank you, Al. Thank you again.
Thank you so much.
Yeah. Bye.
Take care. Stay safe, everyone.
Stay safe, you too. Bye.
Thanks.